Good morning. So for a large part of this year, we have talked quite a bit about the real numbers. If we go back all the way to the beginning lessons that we covered this year, we talked about these sets of numbers. We had the integers and the whole numbers and the rational, irrational numbers, and they were all subsets of this big set called real numbers. And when I define a real number for you, I pretty much said it's any number that's on the number line. If you can find it on the number line, or if you know it exists on the number line, then it's a real number. So even an irrational number like pi, that's like 3.1415, blah, 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 you know that it is somewhere between 3 and 4 on the number line, even if you couldn't point to the exact location where it would exist. And when I introduce that, a question a lot of students have is, well, what's a number that's not real? And people will say, well, like, are they fake numbers out there? Well, they're not called fake numbers, but they are called imaginary numbers. And so the point of this lesson is to introduce to you what the concept of imaginary numbers are. So to begin thinking about that, I want you to consider this question here. Why can't we take the square root of a negative number? And so if you have a calculator handy, like a real calculator, I would like you to do this on your calculator. So try on your calculator. And what I want to do is in class, we're going to stop right here and talk about it. In our virtual class, I'm going to pause. I'm going to give you a moment to try this on the calculator. And then I want you to comment in the live chat what happens on your calculator. If you want to take a picture of what your calculator displays, then and post that in the live chat, you can go ahead and do that as well. Now, the question that hopefully we've talked about and we've looked at is what happens. And there's a variety of things that happen, but generally it's all some version of an error. And the more sophisticated your calculator is, the more specific the error message would be. So a very basic calculator often just has an E pop up on it, like just E for error, and it doesn't tell you anything else about it. Some of them will say domain error. Some calculators will say error, non-real answer. Okay, and non-real gets into the idea of imaginary. So, but unless somebody has actually changed a setting on your calculator, which might have happened for some of you, your calculator will give you an error message. So why does that happen? Why is your calculator kind of bucking back against taking the square root of a negative number? Well, to do that, we need to go back and think about what square rooting does. Square rooting undoes squaring. That is how it's defined. So it undoes squaring. So just to put this in some context, we've seen this before. We have subtraction undoes addition. That's why when you're solving an equation and you have an adding, you subtract to undo it. We also know that like multiplication undoes division and vice versa. So these are pairs of what are called inverse operations, and square rooting undoes squaring. Please make sure that you understand and properly use that vocabulary. I have heard tons of people use these terms interchangeably. They will say squaring when they mean square rooting, and they will say square rooting when they mean squaring. So let's just be really, really clear about what the difference between those two things is. Squaring is when you take something and you multiply it by itself. So for example, 4 squared. So that's what the little 2 means. It literally means you're going to use 4 as a factor twice, and it means to multiply something by itself. Square rooting is represented by that symbol. It looks like a little, like a hook, I guess. And square rooting undoes squaring. So if 4 squared is 16, then the square root of 16 is 4. Okay, and somebody's probably going to say, well, why don't you write plus or minus 4 because you were doing that earlier? There is a reason for it, but you probably won't like it. It just has to do with how it's written, and I will explain that in class or at the end of the lesson if it really bothers somebody, because I know it really bothered me when I was in school. So I don't blame you if it bothers you. I just don't want to stop right now and talk about why do you sometimes put the plus minus and sometimes you don't. So that's what square rooting does. So when you're looking at a square root, what you're asking yourself is, what number squared gave us the 16. That's essentially what the square root is asking there. What number squared gave us the 16? And the answer to that would be 4. So let's go take a look at this one. If you have the square root of -4, what you're asking is, what number squared gave us -4? Well, let's think about it for a second. What number could you multiply by itself that would give you a -4? Well, if you picked a positive number and you multiplied it by itself, so you had a positive number times a positive number, you would get a positive number. So there's no positive number that when you multiply it by itself would give you a -4. So you might think, well, what about a negative number? Okay, well, a negative times a negative, we know from our sign rules, will also give us a positive number. So when we're asking ourselves what number times itself would give us the -4, it can't be a positive number because you multiply it by itself, you're going to get a positive. It can't be a negative number because a negative times a negative gives you a positive. The only other option we have is 0. And 0 times 0 is 0 and still is not negative. And so why your calculator starts yelling at you is that there is no real number that when you square it gives you a negative. So there is no real number that when squared gives us a negative, because we just covered all of it. We covered all the positives, all the negatives, and we covered 0, and there was nothing squared that would give us a negative. And that's why when you go to put this in your calculator will error on you because there's no number for it to find. So that all seems great, and as long as we're dealing with real numbers, this is as far as it goes. It explains why your calculator does what it does, and yet we're not going to stop there. As Professor Santa Cruz in my undergraduate school would say, it will never be as easy as it was. So, introducing what you have waited all year to get to, the imaginary number. What is this number? So let's go through some stuff. The symbol for this number is a lowercase I, and it's usually written a little bit like that. It's usually written a little bit scripted, not like a cursive, but like a little I with a hook on the end. This one over here got a little bit messy, so I'll see if I can go fix it. When you're typing though, so if I'm typing something in a Word document, it will be a regular typed I, but if you go into a math program, it'll kind of make the I look a little bit scripted. It is represented by a lowercase I. It is not a real number, okay? Which means it is not on the number line. So when we look at our number line and we have 0 in the middle and we have our positives and we have our negatives, you cannot find the number I anywhere on the number line. This is a completely new number. It is something we have not encountered before, and yeah, there we go. Now, just as a piece of trivia, because I like to give you guys free information, if you are in engineering, okay, the symbol for the imaginary number is a lowercase j. Probably because I was already taken, because I represents electric current. And so we didn't want to overdo it with the I's. And so in engineering, we would use a J. Now, there are two ways to define I. So we know we have this thing. It's called an imaginary number. The symbol for it is an I. But what on earth is it? So there are two ways to define it. And they're actually the same, it's the same thing, just written two different ways. One is this. I is a number that when you square it, gives you a -1. So the first way to think about it is I squared is equal to -1. Please, 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 please pay attention to that. It is not I is equal to -1. it's I squared is equal to -1. Students will often say I is equal to -1, but that cannot be because -1 is on the number line. And we already have a number for -1. Okay, -1 is 1 unit to the left of 0 on the number line. It means like you've gone $1 in debt or taken 1 step backwards. We already have a number for -1. We don't need another number for -1. We need something new. And in this case, it's the I and I squared gives you -1. Now notice that I might be imaginary, but when you square it, you get something real. The other way to define it is to say the square root of -1 is equal to I. And really these are the same thing, just written 2 different ways. If I took this and I square rooted it, I would end up with this. So it's not 2 different definitions, it's just 2 ways of looking at the definition. So we're gonna do a couple of things here with, we're gonna do a review of simplifying square roots. I know that it can be a little bit of a sore spot for people. And then we're going to do some square roots with the I's in them to see what happens with that. And then I'll share with you a little bit about my first reaction to imaginary numbers, just because we might have a little bit of empathy there. Because if you feel frustrated with this, I do understand you. So let's take a look at a review of simplifying square roots. And we'll do this in much greater detail in a future lesson when we get to radicals. We'll do a lot of this. So here we go. We're going to look at a couple of examples. I'm going to do the square root of 8, and I'm going to do the square root of 72. Full disclosure, the square root of 72 has been on every single test that I've written forever. Okay, when it comes to simplifying square roots. So there's almost a 100% chance that I will at some point ask you to simplify the square root of 72. So let's go through the steps for this. If it is a square root, you are going to factor the number with a perfect square factor. So perfect square factor. Now, just so we remember what perfect square factors are, you could use a 1 squared, but that is not going to help you simplify the square root. So this is one of those times where we're not going to use the 1. But 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, then we have 36, and so forth. Okay, there's an infinite number of them. Yeah, there's an infinite number for perfect square factors. Notice things that are not perfect squares. 2 is not a perfect square. 8 is not a perfect square. 8 is a perfect cube, but not a perfect square. 12 is not a perfect square. 10 is not a perfect square. So we are going to look to factor these numbers using one of the numbers on this list. With the 8, I know that 4 is a factor of 8. So I'm going to go ahead and factor the 8. Now, when you factor it, I want you to put the perfect square on the left. I know that multiplication is commutative, and you don't really need to put numbers on like the left or the right. It doesn't matter with multiplication. You can multiply it in any order you want. But for simplification purposes, I want you to write the perfect square on the left. Next step is to split the square root. And this gets into a property of square roots that we haven't covered yet, but we will. And you should have done it in Algebra 1, which is why I'm not super intense about going through it now. But if you have the square root of 4 times 2, that is actually equal to the square root of 4 times the square root of 2. And then once you simplify that, you will take the square root and you ask yourself, what is the square root of 4? Now, please pay, we want to get this right. The square root of 4 is, if I ask people that question, they will invariably tell me the square root of 4 is 2, and they would be correct. But then they don't write a 2. They write the square root of 2. That's no. We're going to back that up because once you take the square root symbol needs to go away. So the square root of 4 is 2, just plain 2. This over here, the square root of 2, you can't take, and so that comes down. And just as a side note on this is multiplication. Okay, that's what we're looking at there, multiplication. So we don't usually write the times sign there between the 2 and the root 2, but it is. Now the way you would write that, read that out loud is you would say 2 root 2 or 2 radical 2. You might hear somebody put in the word times, okay? So you might hear 2 times root 2, but typically I'll say something like 2 root 2. Now with 72 is an interesting case here. We want to factor the 72 and we'd like to use one of these numbers here. So I'm going to go ahead and it factors into 36 times 2. Okay, and again, put the perfect square on the left-hand side. Just do it. Just like trust me, like you want to do it. Just put the square root of 2 on the left-hand side. Then go ahead and split the square root up. So you'll have the square root of 36 times the square root of 2. And then step 3, take the square root. The square root of 36 is 6. And then just bring down the other square root that you can't take the square root of, and that stays under the square root. The reason I want you to put the perfect square on the left is because one of the mistakes that's very, very common that students make is they will not know which number goes under the square. Seriously? Let me try again. Which number goes under the square root and which number is not under the square root. The number that's not under the square root is the number that comes from taking the square root there. So the square root of 36 is 6, which is why the 6 is no longer under the square root, because you took the square root. The one that is under the square root is the one that comes down. So if you were to do it the other way around, so you were to do the square root of 72, and you did 2 times 36 instead, then you would split it up like this. Okay, remember math is consistent. We work top to bottom. So we would take the square root of 36 and we'd get 6. And now it's like on the wrong side. So you have the 2, which is still under the square root, which it should be, and the 6, which is not under the square root, which we don't want it to be on the square root, but they're kind of written in the wrong order. And so you would have to do this extra step of switching the order on that. Now, I did mention that 72 was on like every test I've ever given, and here's why. Most students don't know their 36 tables. And so it's very common that students will not know that 36 is a factor of 72 just because you haven't dealt with it that much. But somebody in school actually taught you your 8s and your 9s tables. And so students will often do this. They will say, okay, 72 is 9 times 8. Again, put the perfect square on the left. Then they'll do this. They'll like square root of 9 times the square root of 8, and the square root of 9 is 3. Here's the problem with that. That is not simplified as much as it could be. When we simplify a radical, we want to get the smallest number under the square root possible, and the smallest number possible is a 2, and here we have an 8. You can simplify this further. We know that the square root of 8 simplifies because we did it over here. And so this is just like kind of what we're doing with the factoring or simplifying fractions. It's possible to get it part way, and there's still more that you can do. So we could actually break the square root of 8 into 4 times 2. Don't forget the 3. The 3 is right there. And then we'll split it up again. And now the square root of 4 is 2. And 3 times 2 right here is equal to 6. This is doing it in one step over here. Okay, that's one step where you find the biggest factor there. This is doing it in 2 steps where you catch the 9 and then you catch the 4. Remember, 9 times 4 is 36. So it's all tied together. You can totally do it in 2 steps. There's nothing wrong with it. It's maybe not efficient, but there is nothing wrong with it at all. And 72 is the smallest number that does that, where you would have like 2 perfect square factors in there that you could potentially do that. And that's why I put it on the test. So everybody should get the square root of 72 correct because you've seen it done like 2 or 3 different ways now. So how does this apply to negative numbers? So we're introducing our imaginary numbers. Suppose you had the square root of negative 16. Well, I could split that up into 16 times negative 1. Just like we were doing over here, like you take your number and you factor it out. And the way I'm going to factor that out is I'm going to split it into 16 and negative 1. Now I'm going to take the square root of 16 and the square root of negative 1. The square root of 16 is 4. Just remember it's 4, not the square root of 4. Square root is gone. It's 4. And we have recently learned that the square root of -1 is I. And so this is I. And so the square root of -16 is 4I. Here's another example. We have the square root of -18. Well, I'm going to split that up. I have 9 perfect square times 2, but remember it is a -18. So I have to put in the -1. Square root of 9, square root of 2, square root of -1. We split them all up. You do not have to do the split up step, okay? Square root of 9 is 3, just a 3, no more square root, times square root of 2, which you can't simplify, and we have learned recently that the square root of -1 is I. And what we would do is we would switch the order of this just to avoid any confusion about what's outside the square root and what's inside the square root. So only the 2 is inside the square root, the I is not, and the 3 is not. So I'm going to use the commutative property of multiplication and write the I out front. One more quick example of this is the square root of -32. Now, this one has a perfect square factor of 16. And remember, if you don't see it, you can always do it in multiple steps, okay? So if you don't see the biggest perfect square factor, like go for a smaller one and just do it in more than one step. Totally okay to do that. Break this up. The square root of 16. Oops, that's messy. Square root of 16 times the square root of 2 times the square root of -1. Square root of 16 is 4, just 4. No square root, times the square root of 2, and the square root of -1 is I. And then what I'm going to do is bring the I around to the other side. So my answer would be 4I root 2. Now, quick little story. When I learned this in Algebra 2, I learned imaginary numbers in Algebra 2. I hated them. I thought they were the stupidest thing ever. And as most of you know, my mom was a math teacher, and I have a clear memory of getting into the car after school when my mom picked me up and getting angry at her because apparently she was responsible for imaginary numbers. But I just thought it was the stupidest thing. Like, wasn't there enough to do in math anyway without us making up numbers and making it worse? Like, we really, truly had to make up new numbers that didn't even exist. Like, why did I have to, as a Algebra 2 student, learn about numbers that weren't even real? Like, because some mathematician somewhere was so bored and they didn't have enough to do, so they had to make up some new numbers. My mom didn't care. She pretty much just said, learn it anyway. But I did learn in college that they are useful. They are used by electrical engineers, and so all the electronics that you use every day, going into the design of that electronics, people did use imaginary numbers to design that. So I know this seems really random and probably like a total waste of your time, and I do understand why you would feel that way. Just for your knowledge, just know that it is useful, even if it's you're not the one that uses it. So I put 3 practice problems up there. We are going to stop the video at this point so that you can work on the practice. I will put the answers on the next slide so that those of you that are reviewing at home can review your work. So here are the answers to the 3 practice problems. We have 3i root 5, 6i, and 5i root 2. You might notice that taking the square root of negative is exactly the same as taking square root of positive, except that you will have an I in your answer. And that would be completely 100% true. So you do not have to always go through all the reasoning for this. Just know that when you take a square root of a negative, there will be an I in it. As long as you understand where that I comes from and why that I is there, then I'm completely okay with you taking the shortcut.